Hi, welcome back to my YouTube channel. So I hope you guys are doing well. So in my last video, what I told you, in my last video, I just tell you how you can just go through model wizard. Now, uh, uh, in this video, I will tell you how can you just set up your um, COMSOL interface using blank model. So today I'm going to use blank model to set up our COMSOL interface. So let's get started. So first you have to click on blank model. So it will directly give you the interface that we learned from the last video. So in our last video, what we see that we get our geometry as well as physics and study part, right? But in this interface, you can see that we don't have nothing because we didn't select anything yet, right? That's why to set up from this interface, what you have to do, you have to go through add content. Okay, so as you can see, when we go through model wizard, then initially we got 3D, 2D, or 1D, which domain we want to actually work. So for this video, let's say we are going to select 3D. Okay, so let's select 3D. So it's actually it's actually give you the 3D component of geometry. Okay. So then what we need, we need to add physics, right? So to add physics, you have to go through the physics part. So here you can see that you will get a add physics. So click on add physics, just one click, okay? So then you will get the same kind of interface as we seen before in our first video. We seen that we do have lots of group of physics actually. So in the first physics, you do have ACDC model, or so, I don't want to explain all those things because I already explained this kind of things in my first video, right? So for today's video, let's say we are going to add heat transfer in solid as a physics. So let's add it. So double click here, then it will add automatically. So it will take a few seconds. Don't worry. So here you can see that we get the heat transfer solid. Okay. So then what we need to add extra. Okay, we need to add mesh. Okay, so we can add mesh later. But okay, so we get a automatic mesh, so we don't need to add mesh right now. Then we have to add study. So from add study, click on add study, then you will get this kind of interface. So you can add time domain or stationary. So we add a heat transfer in solid. So I told you before that for a specific physics, we do have a set of study. Okay, so for this heat transfers in solid, for this physics, COMSOL does have available uh, more study like stationary, time dependent, okay, and thermal perturbation, okay, so so on. So and also eigen frequency, eigen values. So we are going to add time dependence. So let's add time dependent. So in this video, what we are going to learn we are going to learn how you can set up your interface using just blank model. So we just set up our interface using just blank model. So as you can go through it model wizard, or also you can just click on blank model, then you can come you know, out this just come out in this interface, and then you can set up by yourself. Okay, that's all actually. So now what we are going to do, we just want to build a simple geometry, let's say a block. So just click on block and then build selected. Then you will get this kind of block. So it's not that much uh, uh, complex thing. So we can set length as millimeter, then it will change in millimeter. Okay. So let's say the height is let's say 10 micrometer. So yeah, this is actually the okay. Okay, so let's say this is the height. So from material, let's say we are going to add material from library. So add a material from library. So we add actually heat transfer in solid, right? So where is the heat? Okay, fluid picture. Okay, bioheat. So let's say no, not this thing. Okay, so I want a okay. Let's say we are going to add a liquid, right? Like water. Let's say we are going to add water. So if we add water, then you can see that this model does have it's self-defined. So self-define the value of water actually. So we don't need to define them actually. Okay. So now from heat transfer in solid, what we can do? Okay, let's see here. This is the reference temperature. You can change it as well, but I'm not going to change. It's actually the surrounding temperature. Okay, so here you can see that it's solid. But what we are going to go through actually, let's say click on right, then click on temperature. Okay, so let's say temperature of this port actually. Let's say this is uh, three. Okay, 360 Kelvin. Okay, let's say 360 Kelvin. Obviously. Okay, and duplicate this one and deselect this port and select this boundary and write it as 280, 280 Kelvin. Okay, so we select two temperature on two port actually. So then we can mesh this model actually. So this is automatically meshed. Okay, we can create another video for mesh actually in our maybe in our next video. So in time domain, what we can do, we can see how actually um, so temperature of this port actually 360 Kelvin and the temperature of this port is actually 270. So what will happen? We all know that heat will transfer from this surface to this surface, right? So we will see how much time it will take to um, to get equilibrium point of this model. Okay. Okay. So let's say in second. Okay. We may run from 0 to 1 second. Okay. Maybe 0 to 10 seconds. So 1 second. Okay, so you can change it like this, or also you can change it like this. So from a step, from 0, and a step size is 1 and the step size is 1. So replace this is the thing, and then you can click on compute. Then it will start running this model actually. So wait until the simulation is done. Okay, so uh, you can check from progress how much the progress is. So you can drag down this thing. So you can see that it's almost done. Okay, and from conversation plot. Okay, let's say from conversation plot you can see the conversation card. Okay, so from graphs you can see that yeah, here you can see at last second actually at when okay when the time is 0, then you can see that Let me make it large. Okay. So here you can see when time is 0, then the temperature of this top portion is actually 360. This is the white part. Okay. So if we change it in 1 second, then you can see that the flow of heat actually. So here you can see that it is flowing through the bottom to the bottom. Okay. So also, we can see this curve from results. So, from on the plot group. So, we want a line graph actually. So, let's say define cut line. So, it's actually from top to bottom. Mm, So, if we make it transparent, so you can see that it's going to from top to bottom, and we want to see the temperature. Okay, so then plot. So, here you can see that when time is 0, where okay, it's actually running with arc length, so we are not uh, okay. Got it. So when this is for time is 0, and time is 0, here you can see that uh, at the bottom, the temperature is kind of 281.33 Kelvin. Then at when so it's actually running out. I can tell you. So here you can see that it's showing you the result from this port to this port. Okay. So we just see, let me tell you how we can just, okay. If we see with time, maybe, you know, um, data separable. So yeah, not this one, shell expression. So now I don't want to set time, maybe still not working. Okay, it's okay. So yeah, here you can see. So when time is 0, okay, when time is 0, then temperature is kind of 0, and when time is increasing, then temperature is increasing, and so on. Okay, arc length is fine. So this is how it's actually working. So from time selection, you can select from list. So select 0, then you can see the curve for 0. Okay, for so time of 0 second. Okay, and okay, so click on 0 and press Control, and then click on 10, then plot. So this is the curve of 10 second, and this is the curve of 0 second. Okay, so this is how you can check how temperature is sorry, how heat is flowing through the model. Okay, so let's say we just change time to maybe 50 second. Okay, 50 second. Okay, let's say 1 minute. Okay, let's say 60 seconds. So the time separation maybe 5 seconds. It's will be good actually. Uh, Otherwise, if we just take time separation 1, then it will take lots of time. Okay. So just wait until the simulation is done. Okay. It's almost done. Okay. Let's start. So here you can see that this is the temperature of 3D temperature of Earth. So after 60 seconds, what you can see that, let's say, okay. So the distribution of heat is actually is much higher than when after 10 seconds. Okay. So here you can see that the distribution is almost this way, but after 1 minute, you can see the distribution is very good. So you can see from the line curve as well. Okay, so here we select 0 and 10. Okay, so you can select on press control and 60. So you can see that the distribution is kind of this. Okay, after 60 seconds. Okay, let's say after um, make it actually a minute. Okay, so then we can get a good result. So 0 to 5, say, is 1 minute separation, and after we want to see after 10 minutes. Okay, so okay, just wait until the simulation is done. Okay, you can check the conversation plot. Okay, simulation is done. Okay, here you can see that from line graph 0 and 1 second, oh sorry, 0 and 1 minute, we want to check after 10 minutes. Okay, so it's not that much change actually after 10 minutes actually. So from temperature, okay, after 10 minutes, what's happened actually? So the distribution, okay, I'm sorry, maybe. So the distribution actually, okay. So here the temperature is actually uh, uh, it gets saturated actually. I understand the thing, it gets saturated. So when temperature at 0 degree Celsius, okay, no, when time is 0, when after 1 minute, okay, 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 okay. So let's make it. We need the melting point, right? So how much time it will take to melt, right? So let's make it 1. Okay, then check it again. Oh, I got it. Uh, we didn't select it as melting point, right? So 100 degrees Celsius. So we have to make it at least 373 Kelvin, right? Okay, I can see that our very small model actually. So when at 0 second, and this is after 10, sorry, after 10 minutes, right? So here you can see the graph actually. Okay, from line graph, select all, then yeah, boom. Yeah, here you can see that it gets saturated after maybe 1 minute. Okay, that's why all graph is actually overlapped. That's the thing. I think you got it. So all graph is overlapped. That's why we got it that it's actually um gets saturated after 1 minute. So this is how we can do this thing actually. So as well as we can change the material of this thing. So what we learned today, we can how we can just set up our simulation model and how we can simulate the thing. Okay, and now what I can want to tell you that in my next video, what I will tell you how you can just um, export this graph from COMSOL to your any other software or Word file or other things. So how you can generate this image, how you can just import this, sorry, export this image from COMSOL, and also I'll tell you how you can just export this data to Excel or other software in my next video. Okay, and also I will tell you how you can just modify this graph. That's how you can use this graph to your paper. So in your research paper. Okay, so I'll tell you in the next video. Okay, so this is uh, maybe we is the end of this video. So that's the wrap, guys. See you in the next video. See you.